Artificial intelligence is showing promising results in detecting breast cancer, which may otherwise have been missed by radiologists. Researchers in Germany discovered that artificial intelligence can correctly detect interval breast cancers, which develop in between routine screening rounds, usually 24 months in many countries, and can be missed and diagnosed as false negative results. In 2020, there were 2.3 million women diagnosed with breast cancer and 685,000 deaths globally. The peer-reviewed study showed approximately 16% of interval cancers are probably visible during a previous screening, while 1 in 5 may be too subtle for the human eye and can be missed by radiologists. This is known as minimal signs. The findings present an opportunity to detect more cancers at screening with artificial intelligence, which may help detect breast cancer earlier. German deep tech startup 𝗕𝗲 conducted the study, and the results have been published in the European Journal of Radiology. 𝗕𝗲 assessed 2,396 screening mammograms from women who were later diagnosed with an interval cancer. The study found that AI could detect and correctly localize on the mammogram 27.5% of false negative cases and just over 12% of interval signs of cancer. Interval cancers are the ones that just appear spontaneously during the screening interval. What was really interesting was that the algorithm did have some kind of increased suspiciousness score for some of those, despite there being nothing on the image at screening. In 3% of cases, the algorithm could also correctly localize where breast cancer would later appear. The study worked by the algorithm categorizing the mammographies into 3 sections: cancer suspicious, normal, and unconfident. The cancer suspicious studies and the unconfident ones were passed on to the radiologist. So as not to bias the radiologist, they were not told which study could have cancer. If the radiologist made a prediction the algorithm disagreed with, only then would the algorithm raise the alarm. But this doesn't mean that machines will replace radiologists. It's a very collaborative approach where researchers are not fully replacing the radiologist, but they're complementing their skills because the algorithm uses the concept of confidence. The technology holds the promise of diagnosing breast cancer early, which means better outcomes for women, not only in terms of survival, but also in finding cancer at a stage where they are more easily treatable. Artificial intelligence system learns concepts shared across video, audio, and text. Humans observe the world through a combination of different modalities like vision, hearing, and our understanding of language. Machines, on the other hand, interpret the world through data that algorithms can process. So when a machine sees a photo, it must encode that photo into data it can use to perform a task like image classification. This process becomes more complicated when inputs come in multiple formats like videos, audio clips, and images. The main challenge here is how can a machine align those different modalities? Researchers developed an artificial intelligence technique that learns to represent data in a way that captures concepts which are shared between visual and audio modalities. For instance, their method can learn that the action of a baby crying in a video is related to the spoken word crying in an audio clip. Using this knowledge, their machine learning model can identify where a certain action is taking place in a video and label it. It performs better than other machine learning methods at cross-modal retrieval tasks, which involve finding a piece of data, like a video, that matches a user's query given in another form, like spoken language. Their model also makes it easier for users to see why the machine thinks the video it retrieved matches their query. This technique could someday be utilized to help robots learn about concepts in the world through perception, more like the way humans do. The researchers focused their work on representation learning, which is a form of machine learning that seeks to transform input data to make it easier to perform a task, like classification or prediction. The representation learning model takes raw data, such as video and their corresponding text captions, and encodes them by extracting features or observations about objects and actions in the video. Then, it maps those data points in a grid known as an embedding space. The model clusters similar data together as single points in the grid. Each of these data points, or vectors, is represented by an individual word. For instance, a video clip of a person juggling might be mapped to a vector labeled juggling. The researchers constrain the model so it can only use 1,000 words to label vectors. The model can decide which actions or concepts it wants to encode into a single vector, but it can only use 1,000 vectors. The model chooses the words it thinks best represent the data. Rather than encoding data from different modalities onto separate grids, their method employs a shared embedded space where 2 modalities can be encoded together. This enables the model to learn the relationship between representations from 2 modalities, like video that shows a person juggling and an audio recording of someone saying juggling. To help the system process data from multiple modalities, they designed an algorithm that guides the machine to encode similar concepts into the same vector. The model might assign the word pig to one of the 1,000 vectors. Then, if the model hears someone saying the word pig in an audio clip, it should still use the same vector to encode that. They tested the model on cross-modal retrieval tasks using 3 datasets: a video-text dataset with video clips and text captions, a video-audio dataset with video clips and spoken audio captions, and an image-audio dataset with images and spoken audio captions. For example, in the video-audio dataset, the model chose 1,000 words to represent the actions in the videos. Then, when the researchers fed it the audio queries, the model tried to find the clip that best matched those spoken words. Not only was their technique more likely to find better matches than the models they compared it to, it was also easier to understand. Because the model could only use 1,000 total words to label vectors, this could make the model easier to apply in real-world situations where it is vital that users understand how it makes decisions. The model still has some limitations they hope to address in future work. For one, the research focused on data from 2 modalities at a time, but in the real world, humans encounter many data, and they know that 1,000 words works on this kind of dataset, but they don't know if it can be generalized to a real-world problem. Also, the images and videos in their datasets contain simple objects or straightforward actions. They also want to determine how well their method scales up when they use a wider diversity of inputs. SoundCloud buys AI that claims to predict hit songs. SoundCloud has acquired audio AI company Musio, which makes tech that can listen to new music and purportedly identify the hits. The acquisition is meant to help SoundCloud sort through its immense library of amateur music and will become core to SoundCloud's discovery experience. As DIY music distribution platforms like SoundCloud lower the barrier to entry for amateur artists and flood platforms with new music, identifying and promoting the good stuff has become even more challenging. SoundCloud claims that Musio's tools can quickly sift through countless hours of mostly bad music and pick out the songs that have patterns and characteristics that correlate to chart toppers. Acquiring Musio accelerates their strategy to better understand how that music is moving in a proprietary way, which is critical to their success. Though a far cry from the smoky clubs and AR legends of old, artificial intelligence is becoming an increasingly critical part of finding up-and-coming artists. Music distribution platforms TuneCore announced on Friday that it's partnering with LA-based music startup Fuego, which uses AI to match listeners with creators. Meanwhile, competing DIY music distributor DistroKid has an AI bot named Dave that reviews tracks and ranks qualities like danceability and speechiness. A new brain learning mechanism calls for revision of a long-held neuroscience hypothesis. The brain is a complex network containing billions of neurons. Each of these neurons communicates simultaneously with thousands of others via their synapses, and collects incoming signals through several extremely long branched arms called dendritic trees. For the past 70 years, a core hypothesis of neuroscience has been that brain learning occurs by modifying the strength of the synapses following the relative firing activity of their connecting neurons. This hypothesis has been the base for machine learning and deep learning algorithms, but after 7 decades, this long-lasting hypothesis has now been called into question. In an article published recently in Scientific Reports, researchers revealed that the brain learns completely differently than has been assumed since the 20th century. The new experimental observations suggest that learning is mainly performed in neuronal dendritic trees, where the trunk and branches of the tree modify their strength, as opposed to modifying solely the strength of the synapses, or dendritic leaves, as was previously thought. These observations also indicate that the neuron is actually a much more complex, dynamic, and computational element than a simple binary element that can either fire or not. According to this, just one single neuron can realize deep learning algorithms, which previously required an artificial complex network consisting of thousands of connected neurons and synapses. Researchers have shown that efficient learning of dendritic trees on a single neuron can artificially achieve success rates approaching unity for handwritten digit recognition. This finding paves the way for an efficient, biologically inspired new type of AI hardware and algorithms.